Having covered the controls over soil loss and soil formation, we'll now focus on understanding the development of soil profiles. The authors state that soils develop through the additions of materials to the system, transformation of those materials within the system, transfers down and up in the soil profile, and losses of materials from the system. So to take a look at this, there are four main factors that are associated with the development of soils. We have additions of materials, transformations, transfers, as well as losses. Here in figure 3.8, the authors show some of the basic processes associated with soil development. And we're going to cover each of these in this chapter here. First, we have additions, which include precipitation, bringing in materials, and these could be ions or solid particles, but also the production of organic matter. And all of these bring in materials that weren't there earlier and add them generally at the ground surface. Now we also have transformations, and this could be organic matter that had been produced being transformed, decomposed, and processed by microbes, as well as primary minerals that become secondary minerals through weathering processes. Thirdly, we have transfers, and there's materials that get transferred down through the soil profile, and generally this is water moving down and taking materials with it, such as organic matter compounds, clays, ions. But we also have transfers up through the system, and that's generally through plants, and they're going to take, for example, ions and move them up through the system and redeposit them at the top. Fourthly, we have our losses, and as water moves through that system and comes out the bottom, for example, it's going to take with it ions, for example, and that's going to change the development of the soil. Now to go through those individually, first we're going to go through the additions. And we said we can have additions from the outside as well as the inside, and here we're going to think about one of the main additions from the outside. So the authors talk about loess, which translated means loose, and loess is a relatively loose soil, which represents wind-blown sediments. So if you think about the example that we had before, where you can get dust storms that are moving large quantities of soil, this is just an example of an addition from outside the system that alters the soil development. Now, not all additions of dust occur catastrophically like this in large major events, but there's different degrees by which dust and other particles can be deposited into areas due to the wind. Now if you take a look at some of the road cuts, you can start to see cross sections of loess soils. So this is from Nebraska, and what it shows here is a situation where you've had multiple deposits of loess over time. So what they show here is the modern soil surface with a typical soil development, but dark bands that run through these areas. And these dark bands, for example, represent times when there was not a lot of loess deposition and you had development of soil, but then that soil subsequently was buried by other loess sediments. And so these old soils are referred to as Paleo Cells. And these Paleo Cells are soils that were developing just like they are today, but then they became subsequently buried by other loess sediments. So this here is the Peoria loess, which happened during the last glacial, and this was the soil that was there before, and you can see that it was relatively stable, and there was even a stream channel that was present where water had moved through the system. But then there was a lot of dust in there, a lot of loess became deposited, and it filled in that whole channel. The distribution of loess soils in the world is not random. There are certain places where you're more likely to find loess than others. So for example, when we take a look at North America, and we take a look at where you're likely to find loess, there's a large region here in the Central Great Plains and into eastern US, and then other smaller areas in Idaho and Washington, as well as large areas in Alaska where you can find loess sediments. And the reason for this was essentially the ice sheet, the Laurentide ice sheet that covered most of Canada and parts of the northern US. When you have a large ice sheet like this, it's going to generate cold air above it, and that means you're going to have a high pressure system that sits on top of that quite frequently. And because of the descending air, we're going to get a prevailing wind pattern like this above it. And then below it, you're going to have prevailing winds that run counter to that. And those prevailing winds set up in places, go across relatively dry environments, and move large quantities of material and then redeposit them. And that's what set up the general lust patterns that we have in North America today. Now, these lust soils you can also find in other parts of the world, for example, China. And in China, a large part of these areas, off the lust sediments itself, get used to provide shelter. And what's a typical pattern in some of the regions that you find is that they'll go to the soil surface and they'll start digging down somewhere on the order of 10 meters. And then they build a courtyard. And off of that courtyard, they excavate out rooms. And so these are lust sediments, just like we saw in Nebraska, that end up getting used for settlements. Now, additions of materials can also occur from essentially inside the ecosystem. And primarily, this is the production of organic matter by plants that then gets incorporated into soils. So when plants produce leaves, for example, and they hit the soil surface, this is considered essentially an addition to the soils, and it's part of that soil development process. Now, you can also have modification of that organic matter. In grasslands, a large part of those soils are derived from fecal material, dung droppings of the grazers, because they consume a lot of that, the primary production, and that changes the way the soils work too. Another thing that you can have are fires and charcoal production, which are also really important, but are essentially inputs of materials from within the ecosystem to the soil.